This question is the same as part C, really. Again, we are going to graph the derivative of a function. So this one, we're going to graph this derivative. And again, the first step is to put all the significant points in. These are our extremes. We then have when the gradient is equal to 0. So again, recapping, if the gradient, any point that we pick, is going up like that, and that means the ball would roll down the hill, that is considered a positive. If we were to put a ball here, the ball would not roll anywhere, and so the gradient is considered 0. And if instead we were to put a ball that it would roll, I guess, forwards to the right, which would be over here, that is considered negative. All right, so we need a couple of extra points in there. This point here, and this point here. Those are the stationary points. Now, when we have two stationary points, we will have an inflection between them, and that will occur roughly halfway, and that would either be a minimum or a maximum. And again, we can see it over here. So those are all of our key points. We now have to find the gradient of them, and then we will be able to connect the dots and draw our graph. So the easiest ones are going to be our stationary points. Okay? The next ones are our extremes. So this one here is actually quite negative. I might make it a bit more negative. Okay, and then the other one is a little bit positive. So now we have the inflections point on the left. So we can see as we trace this, we kind of have to do a maximum there, a minimum there, and continue up. So we can move those points to their respective locations. And then we can connect the dots. Apologies, just made a bit of a mistake there. These are drawn this way and this way. So that would go up, down, and around. And now we need to put in arrows to represent that they continue on, and we're done. If we don't put in the arrows, we're likely to make or lose mark.